Okay, connected. Now in this question, see, we'll discuss the question related to topic one. I will share this file also with you. After every question, you will find the answers as well. The answers are attached. Okay, but you're not supposed to just write the answer from the key. You have to solve and just for your yeah, check. You will check your answers once you are done with this question. Okay. Now Z is a covalent substance. We will discuss. There are different types of substances. So a sample of a pure solid Z is continuously heated for 11 minutes. So we heat we heat a sample, a pure solid, for 11 minutes. The graph shows how the temperature of a sample, of a pure Z changes during the first 9 minutes. So for first 9 minutes, they sketch the graph for us. Okay. Now, what is the melting point of pure Z? Yes, Hamad. What is the melting point? So how we work out the melting point? Because if we mark the position, this is a heating curve. And I will send this file now on the... No, I will just send now this file so you can also use the same file. So this is a heating curve or a cooling curve? Heating. Because, and they mentioned the substance is solid. So initially a solid temperature increases and then a solid is turning into a liquid. At the temperature at which a solid turned to liquid, we call that as a melting point. Then we have a liquid and the liquid then turn into a gas we call boiling point and then so on. So the question was identify the melting point of a substance. So what is the melting point of this substance? The melting point of the substance is 80. So we will mark 80, write 80 only. The unit is already written, so you're not supposed to write any unit. It's already shown here. Now, the sample of the pure Z began to boil at 9 minutes and it was boiled for 2 minutes. Use the information to sketch on the grid how the temperature of the sample of pure Z changes between 9 minutes to 11 minutes. They mentioned from 9 to 11 it is boiling. So if I draw like this, is it correct? So why it's wrong? Because they are absorbing the energy, so the line needs to be straight. Because the energy is used to break the bond. So when energy is used to break the bond, we are not supposed to show a change in temperature. We are supposed to just show that the temperature remained unchanged. So it started from 9, like this was 9, and then till 11. So, yes. So, so from 9 to 11, the temperature will be constant. Why? Because it is boiling. When a substance boil, the temperature does not change. So we are not supposed to draw a line which is at a certain inclination or angle or gradient. It should be a horizontal line whenever there is a change in the state. The next is the sample of a pure Z was continually heated for 2 minutes and like as you can see, explain in terms of attractive forces why there was no increase in temperature for a pure sample of a Z between 2 minutes and 5 minutes. So, yes. Energy used to break the bonds. And it's of 2 mark. If one thing, energy used to break the bond, you will score 1 mark for this. What there's another point. The horizontal line? No, or that you are reading a answer, previous answer from the scheme. You are reading a previous answer from the scheme. So energy is used to break the bond. What about online session students? Yes, Anas, Hamad. Most, yeah. They go further apart. Yeah, energy. So energy is used to break the bond, and the vibration or the kinetic energy of the particle does not change. Like when we supply the energy, all the energy is used to break the intermolecular force, the force between the molecules. And the speed or the kinetic energy of the molecules does not change. That's why the temperature remain unchanged or a constant. Yeah, I'm writing. Explain in terms of attractive forces why there is no increase in the temperature. So what will happen? The energy is used to break the. So the speed or the kinetic energy of the particles does not change. Because the temperature is not changing. That's why. But they said in terms of attractive forces. Yeah, in terms of attractive forces, why the substance is changing a state and why there's no increase in the temperature. So in increase in energy we use to break the intermolecular force, the particles move away, but the speed at which the particles are moving, that is not changing. Is it clear? Any doubt in this part? Anas, Hamad, Iman, Mohsen? Here. Yes. No, because I contacted them, so no issue. Okay. Describe how the motion of the next is describe how the motion of the particle of a pure Z changes from 0 to 2 minutes. What happened to the motion of the particles? 2 marks. Kinetic, the kinetic increase. Yeah, particle. Yeah, motion, but you have to relate motion with a certain term. Like they will move faster because the temperature is increasing. And what happened because of increase in temperature, the kinetic energy of the particles will increase. Because it's of 2 marks. Describe how the motion of the particle. So what will happen? The particle move at higher speed. Particles vibrate. That is called a motion. Vibration is a. I said particles move, vibrate at high speed. I said particle move, vibrate at high speed. They will move when the temperature is constant. They will move away from each other. Yeah, further apart. The next is experiment was repeated using a solid sample of an impure Z. What happened to a melting point? Melting point decrease, good. What happened to the boiling point? Increase. Because the melting point is a temperature at which a solid turns into a liquid. But if we have an impure sample, the melting point decreases and the boiling point will increase. Now, the next part, we have a pure sample of a Z. Yes, you can write that. a sample of a pure Z was allowed to cool from 120 to 20. The total time was 8 minutes. Starting from point X, sketch on the grid how the temperature of a pure Z. Before this, sketching this graph, you should know the melting and the boiling point. What was the melting point of the substance from this graph? So melting point was 80. What was the boiling point? 220. So the boiling point is 220. Now we have to sketch a result like the graph from 120 to 20. Okay. So like we want to sketch at 120 until it reaches 20 degrees. So first, what will be the state of a substance at 120? Because the melting point of a substance is 80 and the boiling point of a substance is 220. So at 120, the substance will be liquid. So initially the substance will be liquid. And then what will happen? So it will freeze. At what temperature it will freeze? 80. So at 80, it will start to freeze. A liquid will turn into a solid. And then we'll have a solid from 80 to 20. Yes?
Sir, can we, at the temperature of 120 degrees Celsius, can you also say that it's in the form of gas as well as?
At 120?
Yeah, because of it's turning from liquid to gas.
No, it's not. It will turn from liquid to gas at 220 because the boiling point is 220.
Has started.
No, but when the temperature is 220, it will turn from gas to liquid. The boiling point of a substance is 220. We have to sketch a graph from 120. 120, the substance is liquid. Yeah. So we have to start a liquid state. So first, initially, the substance is in a liquid state. So substance is in a liquid. Once it reaches 80.
Therefore, to see, Martin Sims says it is between what? It's not kinetic.
120 to 80. Focus on this question. We are doing it right now. Otherwise, you will lag behind. Like you will ask again the same question.
After this question.
So we have from 120 to 80. What will happen? This is liquid, the substance. Then from 80 to, it's changing a state. So what will happen? So liquid will turn into a solid. So we'll have a liquid turn into a solid. And then again, till what we have to complete? 20, but how many minutes are there in the question? 8 minutes. So I have to reach 8 minutes.
Sir, I have a question.
Yes.
So between in the state where liquid is changing to solids, there would be no temperature change.
No temperature change. When a solid turned into a liquid, liquid turned into a gas, whenever there is a change in state, there is no change in temperature. So the substance, boiling point of a substance is 220. But we don't have at 220, we have at 120. So the 120, it will be liquid. So initially the liquid temperature is decreasing. Then a liquid is turning into a solid and then it will be solid.
Basically, the liquid has boiled. It has become a gas. So then there would be temperature changes and all that. It has boiled.
No, it already boiled. We are not considering that part. The substance already, or a substance was at 220 degrees. That was gas. A gas turned into a liquid, then it's a cooling curve. So a liquid cooled down, liquid temperature decrease. Eventually, it reaches 80 when a liquid turned into a solid.
Saying